Hello my dear friends, how are you all? I hope you all are good and fantastic. So once again, you are very welcome in our lecture number 5 of triangles. Okay, so my dear friends, I hope you are enjoyed our previous lectures. Okay, so now this lecture is going to be again very amazing, so you have to be listen very carefully. Okay, so without wasting the time, let's start. Yes, so now today we will discuss about Pythagoras theorem. Okay, so you already know what is Pythagoras theorem. Okay, and in this lecture we are going to be proof the Pythagoras theorem. Okay, so let's see. So now you know that, let's suppose this is our right angle triangle A, B, C, and right angle at point P. Now you know that this is our hypotenuse, this is our base, and this is our perpendicular, and we can write it as hypotenuse square is equals to base square plus perpendicular square. Okay, I hope you already know about this relation. Okay, so now in this lecture we are going to be proof this relation, means hypotenuse square is equals to base square plus perpendicular square. Okay, so now let's go on. Yes, so theorem number 7 is that if a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, then triangles on both sides of a perpendicular are similar to the whole triangle and to each other. Okay, so this statement says that, let's suppose we have a right triangle like this, A, B, C. Okay, right angle at point B. Now the statement states that if a perpendicular is drawn, means we are drawing a perpendicular from the vertex of right angle of a right triangle, means from the vertex of B, okay, to the hypotenuse, means AC is our hypotenuse. Okay, so this is our perpendicular. Now then the triangle on both sides of a perpendicular are similar. Okay, means it is saying that we have two triangles, triangle 1 and triangle 2. Okay, so triangle on both the sides of a perpendicular are similar to the whole triangles and to each other, means both the triangles are similar, and these triangles are also similar to the whole triangle, are also similar to the what? Whole triangle. So this is our what? D point. So now from this theorem we can say that triangle what? Yes, triangle ADB is similar to triangle ABC, and triangle what? And triangle what? A, sorry, and triangle CDB is similar to triangle CBA. Okay, CBA. Okay, my dear friends, I hope you understand these things. So my dear friends, the order of these triangles are very important. Okay, now these two triangles are also similar to each other, so we can write triangle ADB is similar to triangle BDC. Okay, my dear friends. So now, my dear friends, this is the statement of this theorem. Okay, so now, my dear friends, let's see the proof of these statements, these conditions. Okay, so now, so my dear friends, first of all, we have a right angle triangle ABC, right angled at point B. Okay, my dear friends. Okay, so we have triangle ABC, okay, right angled at B. Okay, I hope you get this point. Now my dear friends, we have to draw a perpendicular from point B, okay, from point B on AC. So the perpendicular is this line, okay my dear friends. So now my dear friends, from this we can say BD is perpendicular to AC, and we have perpendicular from B intersecting AC at D. Okay, means that is BD is perpendicular to AC. BD is perpendicular to AC. So now my dear friends, we have to prove like, first of all we have to prove triangle ADB is similar to triangle ABC, means ADB is similar to triangle ABC. Okay, after that we have to prove triangle BDC similar to triangle ABC. Okay, and last is triangle ADB is similar to triangle BDC. Okay, so now let's prove that. So first we are proving triangle ADB which is similar to triangle ABD. We are proving this. So now my dear friends, in triangle ADB and triangle ABC. Okay, so now in this my dear friends, angle A is common. We can say angle A is equals to angle A, which is what? Which is common. Okay, I hope you get this point. Now angle ADB is equals to angle ABC. We know that this angle is what? This is 90 degree, and we also know that this angle is also 90 degree. So both the angles are 90 degree. So my dear friends, we can say triangle ADB is similar to triangle ABC by what? By double A similarity criteria. Okay my dear friends. So now my dear friends, if in the two triangles, okay, two corresponding angles are equal, then we can say that these two triangles are similar by double A similarity criteria. Okay my dear friend, I hope you get this point. So first case, hence proof. So this is our first case, we can say hence proof. So now let's move on to the second case. Now my dear friends, we have to prove triangle BDC. Okay, triangle BDC is similar to triangle ABC. Okay, so now my dear friends, in triangle BDC and triangle ABC. Okay, so now here is angle C is equals to angle C. This is common angle. Okay, second is angle BDC, angle BDC and angle ABC, which is equals to 90 degree. We know that my dear friends, this is 90 and this angle is 90. So again my dear friends, we can say that triangle BDC is similar to triangle ABC. Similar to triangle ABC. C. Again, this is by what? By double A similarity criteria. Double A similarity criteria. Okay, my dear friends, I hope you get this point. So this is the second case which we are proving this. Okay, and we can say hence proof. So now let's move on to the third case. So now, my dear friends, in this case, here is from the case 1 and from case 2. If we observe that triangle ABC, okay, is similar to triangle ADB, and here is also triangle ABC is similar to triangle BDC. So my dear friends, we can say that from case 1 and case 2, we can say that triangle ADB, which is similar to triangle ABC, and triangle BDC, which is similar to triangle ABC. Okay, so now, my dear friends, we can say that if one triangle is similar to another triangle and second triangle is similar to third triangle, then first and third triangle are similar. Means if one triangle is similar to another triangle, okay, and second triangle is similar to the third triangle, we can say that these triangles, we can say these triangles and these triangles are similar to each other. Okay, since we can write it as triangle ADB is similar to triangle BDC. Okay, hence proof. So my dear friends, I hope you understand these things. So this concept is same as if A is equals to B and B is equals to C, then we can say that A is equals to C also. Okay, so this concept is same as like this. Okay, my dear friends, I hope you get this point. So now let's move on. So the next theorem states that in a right triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. Okay, it is saying that in a right angle triangle like this, A, B, C. Okay, so now it is saying that in a right triangle, the square of the hypotenuse, means this is H, is equal to the sum of the other two sides. Let's suppose this is this is a right angle triangle, this is a base B, and this is our perpendicular P. Okay, this is our hypotenuse. So we can write it as we need to prove what? AC square is equals to AB square plus BC square. Okay, we need to prove this relation. How we can prove this? So let's start. So now, first of all, we have to draw a line. We have to draw a perpendicular line on hypotenuse, okay, at point D. Okay, so we can write as BD is perpendicular to EC. Okay, and now we can write it as also triangle ADB is similar to triangle ABC by theorem 7. Okay, by what? By theorem 7. So we can write is so AD upon AB is equal to AB upon AC. Okay, so I hope you understand these things. These are sides are proportion. So now, or we can write it as, if we cross multiply, this becomes AB square is equals to AD dot AC. Okay, this become what? AD dot AC. So this is our first equation. Okay, and with the help of second condition, means with the help of what? With the help of second condition, like we have also what? Triangle CDB is similar to triangle CBA. Okay, so this is again by what? By theorem. This is theorem. By theorem 7, you can write it as CD upon BC, okay, which is equals to BC upon AC. Okay, and if we cross multiply, we get CD dot AC is equals to BC square. Okay, so this is our second equation. So if we are adding equation 1 and equation second, so we get what? We get, so after adding the equation, we get what? AB square plus BC square, which is equals to AD dot AC plus CD dot AC. Now in this case, we can take AC as a common. We get AD plus CD. Okay, and this is our what? This is our AB square plus BC square. Okay, so now AD plus CD. What is AD plus CD? If we see in the figure, AD plus DC. AD plus DC or CD, the same thing is. So we get AC. So we can write here as AB square plus BC square. We get AC dot AC. So this will become AC square is equals to AB square plus BC square. Okay, I hope you understand these points. So this is the proof of Pythagoras theorem. So my dear friends, I hope you understand this, how to prove the Pythagoras theorem. Okay, so this theorem, first of all, this theorem was earlier given by an ancient Indian mathematician, Bodhya, about 1800 BCE. Okay, so now let's move on. Yes, theorem number 9. Okay, so in a triangle, if square of one side is equal to the sum of the square of the other two sides, then the angle opposite the first side is a right angle. Okay, this statement states that basically this is a converse of the above statement. So my dear friends, according to this statement, let's suppose we have a right triangle like this. This is our right triangle. Okay, A, B and C. Okay my dear friends, I hope you get this point. So now in a triangle, if square of one side means, let's suppose we are taking AC, means square of one side, which is AC square. is equal to the sum of the square of the other two sides, means is equal to the square of the sum of the other two sides, AB square plus BC square. Okay, my dear friends. Then the angle opposite the first side, means the angle opposite the first side, means this is our first side. Opposite this first side, this is the angle. So this angle is what? This angle is right angle. This angle is what? Angle B is equals to 90 degree. So this is the theorem. Okay. Now my dear friends, we have to prove this theorem. Okay. We have to prove how angle B is equals to 90 degree. Okay. Yes. So now my dear friend, first of all, the given part is, first of all, we have a triangle ABC. We have a triangle ABC. We have a triangle ABC. In this, AC square is equals to AB square plus BC square. Okay, this is the given. So now my dear friends, and we have to prove angle B is equals to 90 degree. Okay, so now first of all my dear friends, we have to do construction. Like first we have to draw a triangle PQR. We have to draw a triangle PQR at right angle at Q. Okay, we have to draw a triangle PQR right angle at point Q. Okay, my dear friend, such that draw triangle PQR right angle at Q such that PQ is equals to AB, means this line is equals to this line. Okay, and QR is equals to BC, means this line is equals to this line. Okay, now my dear friends, now in triangle PQR, we know that this is right angle triangle, so we can say that we know that angle Q is equals to 90 degree. Okay, with the help of this we can write PR square is equals to PQ square plus QR square by Pythagoras theorem. Okay, I hope you get this point. So now my dear friends, and we know that PQ is equals to AB and QR is equals to BC. This is by construction. Okay, so now my dear friends, here is we can place. So my dear friends, we can write AB in place of PQ. Okay, and BC in place of QR. Okay, so this equation will become like PR square is equals to AB square plus BC square. This is the first equation. I hope my dear friends you understand these things. Okay, and now my dear friends, we know very well that AC square is equals to AB square plus BC square. This is what? This is given. Okay, and this equation we are named as second equation. So now from equation first and second, okay, RHS part is equal, so we can write like from 1 and 2, we can write PR square is equals to AC square, which give PR is equals to AC. So this is our third equation. Okay. So now my dear friends, in triangle ABC and PQR, in triangle ABC and PQR, we can write, so in triangle ABC and triangle PQR, AC is equals to PR. Okay, this is from 3. AB is equals to PQ and BC is equals to QR. This is by construction. By construction. Okay. Now my dear friends, so we can say that since triangle ABC is congruent to triangle PQR, is congruent to triangle PQR by triple S rule, by triple S congruency rule. Okay, I hope you get this point. So now my dear friends, we can say that angle B is equals to angle Q. This angle B is equals to angle Q. Okay, by what? By CPCT, means corresponding parts of congruent triangle. Okay, so now my dear friends, here is, we know that angle Q is equals to 90 degree. 90 degree by construction. By construction. So we can say that angle B is also equals to 90 degree. Angle B is also equals to 90 degree. Hence, proof. I hope my dear friends you understand these things. Okay. So now my dear friends, let's do some problems. So the question number 1 is, what is the question number 1? Question number 1 saying that sides of triangles are given below. We have sides of triangle. So determine which of them are right triangle. Means we have to find these sides are the these are the sides of right triangle or not. In case of a right triangle, write the length of its hypotenuse. Okay. So in case this satisfies the right triangle, this satisfies the sides of a right triangle, we have to identify the length of hypotenuse. Okay, so we have first question is 7 centimeter, 27 or 24 centimeter and 25 centimeter. Okay, so just let's do that. So we have the sides of a triangle is 7 centimeter, 24 centimeter and 25 centimeter. So squaring the length of the sides, then we will get, if we square 7 centimeter square, we get 49 centimeter. If we square 24 centimeter, we get what? 576 centimeter. Okay, and if we square 25 centimeter, we get 625. Okay, my dear friends, I hope you understand these things. So if we add 49 plus 576, which is equals to 625. Okay, and we have what? We have 625. Okay, hence proof. So now we can write it as 7 square plus 24 square, which is equals to 25 square. So we can say that what? So the above equation is satisfied Pythagoras theorem. Hence it is a right angle triangle. It is what? Right angle triangle, and length of hypotenuse is what? 25 centimeter. This is our answer. So now let's do the second question. So the second part we have, in the second part, sides are what? Sides are 50 centimeter, 80 centimeter and 100 centimeter. If we square these sides, means if we square 50, we get what? We get 2500. If we square 80, we get 6400. And if we square 100, we get 10,000. So now if we add 2500 plus 6400, okay, from which we get what? We get 8900, which is not equals to 10,000, which is not equals to 10,000. So we can say that the sum of the square of the length of two sides is not equal to the square of the length of the third side. So therefore the given triangle does not satisfy the Pythagoras theorem, and hence it is not right triangle. It is not right triangle. I hope you understand these things, so my dear friends. So now let's move on. Yes, so the question number second is PQR is a triangle, right angled at P, and M is a point on QR such that PM is perpendicular to QR, and show that PM square is equals to QM into MR. Okay, so this question states that, so let's suppose we have a triangle like this. This is a triangle P Q R. Okay, PQR is a triangle right angled at P, and M is a point on QR such that PM is perpendicular to QR, means this is a perpendicular line. This is like this. This is perpendicular line and this point is M. Okay, I hope you understand these things. So now we have to prove what? We have to prove that PM square is equals to QM multiplied by MR. Okay, PM square is equals to QM square multiplied by MR. Oh, sorry, QM multiplied by MR. Okay, so now in triangle PQM, in triangle PQM, by Pythagoras theorem we can write it as okay, PQ square is equals to PM square plus QM square. How? Listen, this is in this triangle PQM, in triangle 1 our perpendicular is this, and in the opposite side opposite to this perpendicular is hypotenuse. So we know that hypotenuse square is equals to base square plus perpendicular square. So we can write it by Pythagoras theorem. Okay, I hope you understand this thing. So now in this case PM square is equals to what? PQ square minus QM square. This is our first equation. We can write it as also. And now in triangle PMR, in this triangle PMR, and in this case we have PR square. Okay, PR square is equals to PM square plus MR square. Again by what? By Pythagoras theorem. Okay, so now In this case we have to find the value of pm square, so we can write it as pm square is equals to pr square minus mr square. Okay, so this is our second equation. Okay, so now adding equation 1 and second we get. Now adding equation 1 and second we get. So we get what? We get, now if we are adding pm square plus pm square, and what is first equation? Our first equation is pq square minus qm square. pq square minus pq square minus qm square, okay, plus, and from second equation pr square minus mr square. Okay, so this will become twice of pm square, which is equals to, now here we can arrange this as pq square plus pr square. Okay, pq square plus pr square, and it will become minus what is the left? We have qm square plus mr square. Okay, so now if we observe pq square plus pr square is what? pq square plus pr square, we get qr square by Pythagoras theorem. Okay, so now we can write it as what? We can write it here, it will become qr square. Okay, and we have minus qm square plus mr square as it is. Okay, and we can again expand qr square as, we can write qr as qm plus mr. We can write what? qr square as qm plus mr whole square, and it is have qm square minus mr square. Okay, now if we expand this, we get qm square plus mr square plus twice of qm dot mr minus qm square minus mr square. Now from this will be cancelled, qm square and mr square. Now we have twice of qm dot mr, and we have twice of pm square. So this is our required statement. So this is our required result, and we write hence proof. I hope you understand these things. Okay, so you have to understand the basic concept of this question. What is the basic concept? So the main key concept is on Pythagoras theorem, and you have to apply this Pythagoras theorem, and you have to add, and you have to equate these equations. Okay, after this you can easily find the values. Okay, so my dear friends, I hope you understand these things. So now let's move on. Yes, question number third. So what is question number third? So question number third is ABC is an isosceles triangle, right angle at C, and we have to prove AB square is equals to twice of AC square. Okay, so let's do that. So now first draw the right triangle. Okay, now we are drawing right triangle. Okay, so this is a right triangle ACB, because right angle at C, and this is a isosceles triangle, means this side is equals to this side. Okay, so in triangle ACB, we have angle C is equals to 90 degree. Angle C is what? 90 degree. And we have AC is equals to BC, isosceles triangle property. So we can write it as AB square is equals to AC square plus CB square by what? By Pythagoras theorem. By Pythagoras theorem. Okay, Now we know that AC is equals to BC, so we can write easily AB square is equals to AC square plus, in the place of CB we can write AC, so it will become AC square, and we have AB square is equals to twice of AC square. This is we want, and hence proof. Okay, yeah, so very easy question. Now let's move on. Yes, so the question number 4th is, what is question 4th is, ABC is an equilateral triangle. ABC is what? Equilateral triangle of side 2M. Find each of its altitudes. Now we have to find all altitudes. Okay, so now let's draw the equilateral triangle. Let's suppose this is equilateral triangle, and the A, B, C, and each side is twice of A, twice of A, twice of A. Okay, so this is the equilateral triangle of side 2A. So now we have to draw an altitude which is perpendicular to BC at point D. At point D, let's suppose this is our D point. Okay, now in triangle ADB, this triangle ADB, triangle 1, and in triangle ADC, second triangle ADC. Okay, we have AB is equals to AC by equilateral triangle property, because all the sides are equal, and AD is equals to AD, which is common side, which is what? Common side, and angle ADB is equals to angle ADC, which is 90 degree. Okay, so therefore we can say that triangle ADB is congruent to triangle ADC by what? By RHS criteria, by RHS congruency. So what is RHS? RHS means in this case we have what? We have one right angle and one hypotenuse and one side. Okay, one hypotenuse, one side, and one right angle. So we can say that these two triangles are congruent by RHS rule. So we can say again, BD is equals to DC by CPCT, means corresponding parts of congruent triangle. Now in right angle triangle ADB, okay, we have AB square is equals to AD square plus BD square. Okay, now we have AB is what? Twice of A square, equals to, we don't know, AD square plus, and we know A square. Okay, so we have AD square is equals to 4A square minus A square, and we get 3A square. Okay, and if we take under root both this side, we get AD is equals to root 3A. So we have a value of AD is what? We have value AD is root 3A. Okay, so I hope you understand these things. So the main focus, what? So our main focus to find this is, we want to know the value of this. Okay, so if this is equal, so we can say the value of BD is A and DC is what? DC is A. So this is the main reason to do these steps. Okay, so behind every step there is a reason. Okay, so now let's move on. Yeah, so the next question is, a ladder 10 meter long reaches a window 8 meter above the ground. So find the distance of the foot of the ladder from the base of the wall, from the base of the wall. Okay, so now we have a ladder 10-meter long. Let's suppose like this, 10-meter long, 10-meter long, a window 8-meter above the ground. Okay, so now let's suppose this is a ground and this is 8-meter, the distance is 8-meter, and this is a ladder which is 10-meter. Okay, this is a ladder and these points are A, B and C. Okay, now we have to find the distance of the foot of the ladder from the base of the wall, means we have to find this distance. So very easy guys, how we can find it? Yes, of course. So BA be the wall and AC be the ladder, means we can say that this is a right angle because our wall is straight. Okay, so this is a right angle and this is our hypotenuse, this is our perpendicular, and this is our what? This is our base. So by Pythagoras theorem, okay, we can write AC square is equals to AB square plus BC square, and we know the value of AC is what? 10 square is equals to, this is 8 square, and we have to find BC. So this will become 100 minus 64. Okay, and this is the result is 36 BC and BC square, and if we take under root both the side, we get what? We get BC is equals to 6 centimeter. Oh sorry, 6 meter, because all the values are in meter, so 6 is also in meter. Okay, so now this is our required answer. So how easy the questions are. Okay, so this theorem, this Pythagoras theorem is very important. Okay, so there are a lot of application of this Pythagoras theorem. Okay, so now let's move on the another question. So the question number 6 is a guy wire. Okay, a guy wire attached to a vertical pole of height 18 meter is 24 meter long and has a stake attached to the other end. So how far from the base of the pupil should the stake be driven so that the wire will be taut? So let we have a pole, let this is a pole which is of height 18 meter. Okay, this is a pole which has 18 meter. Okay, and this wire and a wire attached to the end of this pole which is 24 meter. Okay, now we have to find this distance, so this is A, B and C. Okay, again we can do it by Pythagoras theorem. Okay, so we can do directly AC square is equals to AB square plus BC square. And what is AC? We have AC is 24, means 24 square is equals to, what is, this is our AB, this is AB. Okay, AB square. And what is AB? We have AB is 18 square and we don't know the value of BC, so we have to find the value of BC. So what is the square of 24 centimeter? Can anyone tell me? So the square is 576. And what is the square of 18? So the square of 18 is 324 plus BC square. So BC square is equals to 576 minus 324. Now if we subtract, we get what? We get 252. And this is BC square. Now if we take under root both the side, we get BC is equals to 6 root 7 meter. So the value of BC is this. So my dear friends, I hope you understand these things. So the Pythagoras theorem are help us to find the distances, to find the hypotenuse, and to find the height of like height of tree, height of ball. Let's suppose in this question, if the distance we have already given, and if we want if we have to find the height of ball, we can easily find with the help of Pythagoras theorem. So the Pythagoras theorem is very important in our daily life also. Okay, so in this lecture we have seen what the proof of the Pythagoras theorem and the lot of applications of the Pythagoras theorem. So based on this lecture and till lecture we have already taken, okay, so based on these lectures you are able to solve a lot of problems based on these topics. Okay, so now my dear friends, this is enough for today, and we will meet in the next lecture. So then, goodbye and take care.